Welcome to an example in which we are multiplying using the lattice method. So we did some adding using the lattice method in a previous homework, and now we're going to multiply using the lattice method. So before we do, let me first remind you how we do normal multiplication. 26 times 47. Let's go down here and let's just do the normal method, which is also called an algorithm. An algorithm is a method, a way of doing something, right? The normal method. What's the normal method? What do we already forgot the numbers? 26 times 47. Okay. 26 times 47. Doesn't matter which one you put in the top and the bottom. What's the normal way? Well, you know, you take the 6 and you multiply 6 times 7, 42. And then you take the 6 and you multiply the 4. 6 times 4 is 24. Add the 4, 28. Right? That's how you start. Let me erase these now. And then he's done, and now you start with the 2, and you go 2 times 7. You start add a 0 there. 2 times 7, 14, and 2 times 4 is 8. Add the 1, 9. Then you add these up. 2, 8, and 4 makes 12. Carry the 1. What's that? 12. There's our answer, 1222. That's the normal method. That is definitely how you should teach younger folks to multiply by hand. I know we use our calculator and everything, and you can totally use your calculator on the exam. But you will teach younger folks how to do this by hand, if you're at that age group anyway. And so this is the normal method, the standard algorithm, and that's how you should teach it. But to give you better perspective on the standard way, let's come up here and let me show you a different way. Again, that gives you wider, deeper perspective on what multiplying really is. Okay, so here we go. I'm going to make a big lattice array here, and what that means is I'm going to make 2 by 2 boxes, and I'm going to put in this diagonal here, and that diagonal, whoops, that did not look so good, did it? Well, we'll just say it's well, here actually I can do better. Let me try again. All right, let's do that and let's do it in pieces. There we go. All right, good. So that's a lattice array. Like I'm just basically doing this thing is all I'm doing. So we have a lattice array. Okay, and and now what do? You put the numbers up around the numbers they're giving you around the object. So start with the 26. That's going to go here, and then the 47 go there and there. So let me put those in. 26, 47. So the first number just goes across the top, second number down the side. And now you're going to multiply by multiplying the individual digits. By the way, notice this is different than the grid method because I don't write 20 and I don't write 40. I just write 2 and 4. Okay, so what do we do now? So now we multiply the digits. So column by columns and rows. So I'm going to multiply these two. 4 times 6, going to be 24. Doesn't matter what order you do this in. 6 times 7, just the rows and the columns multiply. That's going to be 42. And then 2 times 4, that's going to be 8. You go 0, 8. And 2 times 7, 14. Okay, so now where do we go to get our answers? Well, you remember what you do for lattice? Same thing for multiplying as we did for addition. You go down the diagonal. That diagonal, that diagonal, that diagonal, that diagonal. You add, I should make a little arrow here. You add down the diagonals. Like that, like that, like that, like that. Right? Add down the diagonals. Okay, so what do we get? This is just 2, 4, 4, 4. What does that make? Well, 12. That'd be a 2 there, and you carry a 1 to the next diagonal. And then 1 and 2 and 8, that's 8, 10, 11. 8 and 2 is 10, 1 is 11, 12. So that's 2, carry the 1. And 1 and 0 is 1. Like that. Right? And what's our answer? It's right here. Remember, it's not It's not the 2, 6, 4, 7, because the 2, 6, 4, 7 were the original numbers. So the answer is 1, 2, 2, 2, which I was looking at here to prove it's the same. Same answer we got with the standard method, standard algorithm, isn't it? It's exactly the same answer. 1, 2, 2, 2. That might seem weird to you. Do you see how that happened? So now we can fill in all the A's and B's and C's. So let me just write them in there. This is A, or actually I could probably just bring them over. How about that? So this is 0, 8, 24, and 42, and 14, and this right here became a 2, this right here became a 2, this right here became a 2, and this right here became a 1. So now we can fill them all in. A is 2, B is 6, C is 4, D is 7, E is 0, F is 8, G is 2, H is 4, I is 1, J is 4, K is 4, L is 2, M is 1, N is 2, O is 2, and P is 2. And the final answer, 1, 2, 2, 2, which we could have got off our calculator in 2 seconds, but nevertheless, this lattice multiplication works. So again, highlighting, what did I just do? I just took the original numbers, 26 and 47, put 2, 6, and 4, 7. And then I just multiplied rows and columns. 4 times 6, 24. 6 times 7, 42. 2 times 4, 0, 8. Right? 2 times 7, 14. We're multiplying rows and columns. And then you add down the diagonal. That's 2. 4, 4, 4 is 12. So this I put a 2 there, and I carried the 1 to the next diagonal. So the diagonals are the focus. So then this 1 with 2, 8, and 1, that made 12 again. 2 carried the 1. And then I added down this diagonal, 0 and 1 is 1. And then there's the answer, 1, 2, 2, 2. So you're just multiplying all the rows and columns. And what makes the carry happen is the diagonals automatically carry things for you. Right? When I go 6 times 4 is 24, the 2 ends up here and the 4 there, so the 2 is already carried because it's in the next diagonal. That's why the lattice method works fairly nicely, because it does the carrying automatically. But we did have to carry again when we did 4, 4, 4, which is 12, 2 here, and we had to carry the 1 later. So we did have some later carrying to do also to complete that. So that's how that works.